All right, everybody, please grab a seat. Your next talk is starting now by Hari. It is on which messaging layer you should use in a loosely coupled distributed app.
Oops, sorry. Why is this showing in this mode? Okay, I think. So, hello everyone. My name is Hari. It's been a wonderful last few days here at PyCon. And I'll be speaking to you now about which messaging layer you should choose if you want to build a loosely coupled app in Python. So before we start off, just to set some expectation on what I'm going to talk about. I'm a Python hobbyist, but for the last 9.5 years, I've been working with building large-scale enterprise systems in where we build a messaging layer between the various systems in places like banks and big companies. So what I'm going to talk about today is if you want to build a loosely coupled app and you have made up your mind that that is exactly what you want, you need to make a choice on what software or which messaging layer you will use for communicating between various components of your system. So that is a choice which you need to make, and I'll just walk you through a few things which you need to watch out, and then you can make a decision based on that, what exactly you want to use, right? So when I say a messaging system, there can be two kinds of messaging systems. One is you take a large size organization which has a very good number of IT applications which have been built over a period of many years, and they want to speak to each other. That's one way. And the other one is where you have an application, but you want to take some part of your work and you want to offload it onto some sort of an async processing queue like Celery or something like that. So both of them have the same common requirement that you need a messaging layer. So let's say there is a large company where all the applications want to talk to one another, and they built some interfaces between each of them over a period of years, many years. Somebody came in and said, I want to talk to this application by sending a file. Somebody said, I want to send an XML feed, and you build something. Everybody speaks to everybody. And what it results in is a big mess. You have people talking to each and every application. Maybe there's a control, maybe there's a format, but it's a mess. It's not very easy to manage. If you do it properly, if you don't make a mess, then you get messaging, where each system talks to each and every other system using a common messaging layer. It could be a message queue, it could be RPC, it could be just UDP, whatever it is. But everybody uses a single mechanism. That is what messaging is about. And this brings an amount of control into your system. You can control what is going on. You know where to look in case there's a problem. And because the flow is something which works, as you keep on adding more applications onto that, the chances that you will end up in a catastrophic failure are very less. You know that I added this system, it was working before that, I removed this, it should work again. Something like that. And the other thing which I was talking about is if you want to offload your tasks onto a async processing library, then you have a bunch of applications which put things on a message queue, and then you have a bunch of workers picking up from them. This is very similar to the previous one, except that here we had a variety of systems, and here we have a master sending jobs, and we have a bunch of workers picking up the same thing. Workers could pick up the same thing, or they could pick each kind of work based on what they're doing. We'll see more about that. So you have made up your mind that you want to build a loosely coupled app. Why? It is very important to understand why you want loosely coupled app, because once you build the application, if it is not performing like you expected, or it's not giving you results which you expected it to give, then you've just wasted a few man-hours of effort or some amount of money. So you need to know exactly what you're getting into. Plus, you need to know what would be the side effects of that. The most obvious thing is, when you take one application and you split it into multiple parts, you have more moving parts. More moving parts always means more chances of failure, and things can fall over. One part of your application could be very fast, and the other part is very slow. This makes the entire system so heavily loaded that others are not able to keep up. These are the kind of problems which you should expect to see at some point. So you sat through a bunch of meetings, figured out that, yes, this is what I want to do in spite of all the risk which I'm seeing. Fine. So what do you need to do? Let's start with the basics. You need to understand what sort of benefits you can get by splitting up your application. That will actually drive how you split your application. Like if I want to split up one part of my application which is related to generating PDF files, and I know that as soon as I put it into a separate processing, some sort of async processing, I can free up the rest of my application to work with something else. But let's say if I want to split up my application and put the part which does maybe the user authentication into a separate thing. There's no point in that because you don't want the user to wait until the message goes across the bus, he gets authenticated, and he gets a response. That's not something which you want to split up. So you need to do that. Then, what are the components which you've finally figured out that these will be the components of my application? How do they interact with each other? Like, can they send a little bit of information across message, and the other part which gets the message, is it able to figure out everything it requires from that? Or is it getting pointers to a cache or to a database or an external web service or something? And is it able to figure out? So all these components have a language in which they speak to each other, which we can call it as a simple, very simple interface between them. But this interface works over messaging. So we need to figure that out. Now, we also need to know that how many instances of each of these components would we need? Like if I'm trying to build something which generates PDF files, then on a normal day when I have about 100 users simultaneously logged in, one instance of that should be enough. But let's say I have a very big day and I have a few thousand people logged in. I need more than that. These are the kind of things which we need to do. And sometimes we had a very good working application, and we decided we want to make it into so many parts. That itself will create a few what you call use cases which were not present in our application. For example, we did a project at one place where we took something which was persisting messages into an Oracle database, and we split it off into something which was sending messages over a simple message queue, something like private MQ. When it was in Oracle, it was possible that if you wanted to replay a message, you could go, pick the message from there, and play it again. But on private MQ, we don't have that. Once you pick a message, it's gone. So what do? We needed to support the record and playback facility. So we started building another component which would sit there and just listen to these messages, record them somewhere. And in the odd case that somebody wanted to replay it, we know where to find the message. We could reconstruct it and we could send it. The other one, previously, if your application was in one place, then it would work in a certain way, and all the people who support the application, you have huge support staff who work on that. They are used to looking for a certain kind of problem. When you split it into multiple parts, you create more problems. They won't expect to see a certain interaction fail. You need to figure out all those and inform them so that it's very easy for them to keep in mind, monitor, and you have a very stable platform. Right? These are the basic things which you need to keep in your mind before you start this. Then, what sort of patterns do you have in your application? So, each and every application has a certain thing which it has to perform every day, which is the bread and butter work. Then you have some things which are performed once in a week, some things once in a month. So there's a very simple rule. You should optimize for the thing which you have to do more often. If you optimize something which happens only once in a month, and the thing which you do every minute, every half an hour takes a long time, it's bad. So you need to identify what your application is doing. And once we have that, then you'll understand that should I do this as a request reply, where it has to wait, which is not very optimum, or should I do a publish subscribe? I just fire it off, wait for it to finish, and then I'll get response from somewhere. These are the things which you need to figure out. Then, you also sometimes end up in situations where you need to separate out messages. If you work for a retail company or for a bank, you have various kinds of messages. A bank gets a report from somewhere, which is a statement of account. That is very different from a message, which is an execution from big ECN somewhere, maybe from NYC. So you need to separate out these messages. Maybe some of them are very important, some of them are not. And also, when you represent these messages, sometimes it's a very good idea to have a schema. That way, you are sure that people don't put things which you don't want them to put there. And if somebody puts a string in a field which is supposed to be float, it will cause problem in the application which picks up your message. So having a schema helps you. If you don't really worry about that, you can put a free-form message, pass a dict, no problem. And the other thing is, like I was mentioning previously, some components have a very high throughput as compared to the others. What happens there is the one which is moving very fast is going to flood the one which is moving very slow. So maybe it's a very good idea to separate them out into separate, to put them into separate layers in your application if you can. That will be something which would also be important. Okay, so in 9.5 years, there have been very few occasions where I've heard someone say, I don't care whether I receive a message or not. Most of the time people say, I need to get the message. You give me the message, even if it's an hour late, and I will figure out whether I want to use it or I want to throw it away. So the most important thing is message should not be lost. But once we accept that, there are a few things which you can play around with, which is latency. Some applications don't care how fast they get messages. They might get it half an hour late. They don't mind. So you can split out applications or put multiple layers in your messaging, have multiple brokers, so that fast and slow can be separated out. Sometimes there is no point in sending a message after a while. Like you wanted to tell somebody that this is failing. You sent a message, but they get the message after that issue is fixed. No point. So although people say they don't want to miss a message, they don't want to get useless messages either. So you might be able to set an expiry on the message. Some of the brokers support this. You put a message there, 1 hour nobody picks it up, expire it. Done. Right? Then the other thing is how can we route messages between various components? So if you've used something like AMQP, that has a concept of an exchange, fan-in, fan-out exchange, and exchange where just each of the input message gets copied onto another queue. So this can be used to set up a business rule that if a message comes from this system, there are a bunch of interested folks who want this. So you set up a fan-out. One message from here, spread it out to 5 systems, right? That's one thing. And next one is, can you make some messages higher priority? So let's say you were sending a message, and you wanted that to be processed before everything else. like you're sending a stop message saying something has gone wrong, stop processing all of these, go and reload the cache. That message has to be at the top of the queue if it has to be picked up first. So is it possible to set priority on messages? This is something which actually happens in banks a lot, but yeah, your application might have requirement for that. Latency, routing, and priority. Those are the important things. Now, we all build systems. Somebody has to manage them and support them. So just like we want our life to be easy and build it easily, there should be a suitable API. It should be very transparent. You should not have to write 15 lines of code each time you want to publish a message. One line, very good. 3 or 4 lines, OK. Then it should be easy to provision and manage. So let's say I want to run my application locally, and I want to start my local environment on my laptop. How easy is that? If I need to install a bunch of brokers, compile a lot of code, and do something, I will not do it. I could use a virtual machine, fine. But if it's very easy, it's very good. It should have very good monitoring. So once you get into this messaging layer, if I have to figure out which message is on the queue or where my message is in the queue, I should be able to do it. Or at least I should know what message is at the head of the queue. And I should see the pending and number of pending messages and all this stuff, right? So those should be there. They should now, like I was saying, nobody ever says they want to miss a message. So there are some cases where you want a guaranteed message delivery. So that is something which we should watch out for, if that is provided. And things like should be persist messages, like if the entire system crashes and it comes back, but at the time of crash, there were about 1 million messages on the system. You brought the system back up, but you don't have one out of those, you don't have any of those million messages. People won't be happy. People are not happy to recreate messages for you just because your messaging layer crashed. There might be a lot of important things. Similarly, in case of issues, if you want to remove a message, you should have facility for that. Because if you're not able to remove a bad message, then it's very bad. It makes things even worse, right? So, a few options. These are all the messaging frameworks, messaging providers, which I've seen when I'm working with Python and few and otherwise. RabbitMQ, that's a proper message queue implementation which has a centralized broker, and it supports a lot of messaging semantics from the AMQP protocol. This is something which I would use when I need a proper messaging layer, something like a bank. ZeroMQ, this is just sockets with a lot of support for messaging on top of that. There is no centralized message broker. So you handle all that stuff in your application. This might work for you if you don't want a broker, you want a client to come up, send messages, you're sure that there are consumers on the other side who want to subscribe to the messages, and you generally don't want to hassle with setting up all that, right? Redis. This is something which I use on my laptop because I don't want to set up a full message broker on my laptop. You could use this for your QA, development, local testing. Redis is just a key value store, but it has publish, subscribe functionality in that. So that also can be used. You could use a RDBMS or a NoSQL database. This can be done like if you only send a few hundred messages per day, you don't really have a load, and you can just persist them as rows in a table. No problem, if it works for you. RPC. This would be like rolling your own messaging framework. You write code over sockets RPC, and then you let your applications worry about how you manage a queue, how you build and maintain a queue, how you consider it a publish, subscribe, and all that. So it's up to you. It's all boils down to how much effort you're willing to put in building and managing it. Considering future growth. Now, the picture you see there is a favorite picture of mine. I've lived there, and I use that line. The reason I put it there. So this line on the metro in Tokyo is very full. So every day in the rush hour, every day close to midnight, and especially on Friday nights, it's full of people. It's so full that you're packed like sardines. And the general saying is, if you can put your hand in, somebody will make sure that you get into the train. And then, very safely, you'll go to your train, people will make sure that you get off the train. And by the time the train has completed its loop, this thing repeats for that 1 hour or so when there's a large amount of people going all across the city, and then it comes back to normal. This is an example of a system which is able to handle a sudden load very efficiently without failing, and it comes out very safe, very happy, it works. So you should consider that today if you're doing 1 million messages, if you had a growth, 15% growth, how would your system cope? What if you had a consistent 1 million messages for 14 hours a day? What would happen? These are the kind of things which you would need to worry about. Plus, once you start doing all these things, if you're doing something where it generates a lot of logs or it persists messages, then your storage cost also increases. Hard disks are very cheap, but what size of files are you willing to maintain? Maybe you want to build another mechanism so that you don't have to persist so much. Use something where you send a message, it's done, you don't persist it, but you record it somewhere else more efficiently. Some things which you need to worry about. And last but not the least, if you have to switch, like if you want to switch from RabbitMQ into something else, how easy is it? If it's easy, as easy as just changing the broker, changing the URL, very good. If it requires a few days of work, fine. But if anything more than a few days, maybe a few weeks, bad. So you need to consider all these things. So what messaging layer you choose finally is a combination of all these things, and it's something which suits your requirements. There's no one single answer. You decide based on all these factors, which one do you need. And then, as the factors in your environment change, as your environment evolves, you get this 15% growth, long run for 24 hours, and all this, you might have to make a choice. So as long as you're prepared for that, it should work fine. So that's all I had to share. And you can find this presentation on SlideShare, and you can reach out to me if you have any questions. Any questions now?
How much time do we have for questions?
I think we have 5 minutes.
5 minutes, okay. When you talked in one of your middle slides about the request-reply model, the publish-subscribe model, and the queuing model,
Yeah.
Am I right in understanding that you're thinking of request-reply as synchronous, pub-sub as asynchronous, and then queuing as, like, there's actually no meaning to talking about synchronous because you're just queuing and dropping something off and never hearing from it again?
Yeah, your understanding is correct on that.
Thanks. And in RabbitMQ, ZeroMQ, Redis, and RDBMS, NoSQL versus RPC, have you used all those things in your own work as well?
I've used the first one, which is a proper message broker, and I've used Redis, which I use to play around when I don't have to worry about any persistence.
We currently use Rabbit for a lot of things, but we're looking at trying out PGQ, which is a queuing system built inside Postgres. Do you have any experience with systems like that that are supposed to handle a high load but also be inside your database?
I've not used PGQ, but there was something similarly from Oracle. I think it was called AQ, and we actually migrated off a system from AQ into proper message broker. I think the one on Oracle worked fine until they were doing about 40 messages per second. Beyond that, it was not able to keep up. So they wanted to do more, so we helped them move to a message broker. So with PGQ, I don't know exactly, but you might hit a point where it is not able to keep up.
One of our problems with Rabbit and Redis and other solutions is that if a database transaction gets rolled back, we've already sent the message or fired the event. Do you have any sort of general solution for dealing with that problem, which is something that PGQ sort of automatically handles because it's trigger-based?
No, I mean, normally if you have a system which is picking up your messages and persisting something into a database, then by design, because it's a fire a message thing, it's not possible to do everything in a single transaction. Publish message, persist, then confirm it's persisted properly, and then commit it. Implementing that sort of thing would require a more careful design on maybe you could send another message to roll back, something like that.
Thank you.
I think we're out of time now, so thank you, everyone.